Hey everyone, welcome back to another video from Tutoring with You. We are a company which specializes in providing tutoring services for all subjects globally. For more details, please contact us at our WhatsApp number below or check out our Instagram and Facebook page. Don't forget to like, subscribe and enjoy the video.
Hey everybody, welcome back to another video of Tutoring with You. Today we'll be going through Cambridge IGCSE Maths Paper 2 Extended from February to March 2024. Let's take a look at the first question. The first question asks us to find the total duration a night bus runs from the starting time at 21:50 to the ending time of 5:18 the next day. So we know that this bus runs through midnight, where the way we display time resets, being both 2400 and 0000. So there are two ways we can do this question. The first way is by finding out the difference in time around midnight. To do that, we will first find the first duration, which we will subtract our starting time at 21:50 from midnight. So, as we can initially see, we cannot subtract 5 from 0, so we'll convert one of these hours into minutes, which we know is 60 minutes, so we will write this as 6. Then subtracting, we can see that the first duration is 2 hours and 10 minutes. Now finding the second duration, we will take the ending time of 5:18 minus at midnight, written as 0000, and we can easily see how it will be 18 minutes and 5 hours. To then find the total time, we will add both of these durations together, giving us a total of 7 hours and 28 minutes. Another way we can do this is to rewrite our ending time as if it did not reset at midnight, the way that we count time. So to do that, we would add to 2400, 5:18, giving us a new end time of 29:18. From that end time, we can then subtract our starting time of 21:50, once again converting one of the hours into minutes. Then subtracting, we can get 8 minus 0, which is 8, 7 minus 5, which is 2, 8 minus 1, which is 7, and 2 minus 2, which is 0. 7 hours and 28 minutes. Then looking on to question 2, we have this equation that they ask us to calculate. To do this, we have to follow BODMAS, which stands for brackets, orders, which are powers and roots, D, which is division, M for multiplication, A for addition, and S for subtraction. So this tells us the order in which we should do operations, starting at the top with brackets and ending at the bottom with subtraction. So here in this equation, we have orders and addition. According to BODMAS, we should do the orders first and additions second. So, evaluating the square root of 5.76 and the cube of 2.8, we will get 2.4 plus 21.952, which gives us the final answer at 24.352. Moving on to this algebraic equation, we have 4m plus 7k minus m plus 3k. So we have to group the like terms together. We have m and k, so let's rewrite this equation to group them together, giving us 4m minus m plus 7k plus 3k, which will then give us 3m plus 10k, as we will add or subtract the coefficients of each of these terms with no coefficient, meaning the coefficient of 1. Alright, so thus our final answer is 3m plus 10k. Now moving on to this question, we have the net of a cube, which tells us certain information about it, with its length being 10, its width being 4, and height being 5 cm. So first looking at the base, we know that this is the length, this is the width, this is 10 cm, and this is 4 cm. Alright, then thinking about the way that this cube will fold, let me draw a cube, void. We know that this face over here will fold along this dotted line to become the face at the back. So we know that this length is the height of 5 cm, which corresponds to here. So then we can take all these lengths that we know and apply it to other parts of the cube, knowing where they connect. For example, we know that all these lines here are all 5 centimeters. We know that this edge will connect with this edge once it's folded, so this makes this 4. Same here, as it will connect with this edge. We know that here is 10 centimeters as it connects with this edge. Same thing with up here also being 10 centimeters, as it's the same length, and here being 4 centimeters. We can apply that throughout the shape. So then looking at the values we need to find, we can first look at A, which we know is made up of 4 centimeters plus 10 centimeters plus 4 centimeters, giving us a total of 18 centimeters. Then looking on to B, we can tell that B is equal to 10 centimeters, as is the same length as down here. We know that C is 4 centimeters, and D is 5 plus 4, which is equal to 9 centimeters. So that gives us the final answer of A being 18, B being 10, C equals 4, and D equaling 9. Now moving on to question 5, we're asked to find the angle of the sector of a pie chart. Right? So a pie chart divides its total angle of 360 degrees proportionally to the data is trying to represent. So what this means is that we have to find the ratio of angles. So we know that the fraction of cars that are blue is 3 out of the total 20 cars, and we can multiply that by the total 360 degrees, which will give us an answer of 54 degrees. So 54 degrees is 3 over 3/20ths of 360 degrees. Then, looking at question B, one of the 20 cars is picked, and we want to find the probability that it is not blue. So we know that out of the 20 cars, 3 are blue. So to find the number of cars that are not blue, we will do 20 minus 3, which is equal to 17. So then, out of the total cars, we know that 17 of them are not blue. 17 out of 20 cars is our probability. Then looking on to question 6, we're asked to find A, B as a column vector. So we're going from A towards B, so we're going in this direction. First off, we should remember about vectors is that this way in the y-axis is positive, while this way in the x-axis is positive. So going from A to B, let's first look at the x-axis. We know that it starts at 7 and ends at minus 3. So if we want to do a calculation, we can do it as the end minus the start to find the difference. So that's minus 3 minus 7, which is equal to minus 10. And for the y values, we start at 1, ending at 4. So that's 4 minus 1, which is equal to 3. So that would then tell us that our column vector is minus 10, 3, as you write the x value on top and the y value on the bottom. To double check our answer, we can also just simply do this question by counting the number of squares to travel between A and B. So first, going this way, so you can count 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Going this ways, so we know that's negative. And going 1, 2, 3. Going this way, so we know it's positive, giving us negative 10. That's the x value, and 3 as the y value, which is the same as what we calculated. Moving on now to question 7. We want to find the type of correlation. So let's see what the information tells us. It says, as temperature increases, the number of people who go swimming also increases. So when the first value goes up, and the second value also goes up, what type of correlation is this? Let's try and just draw a quick sketch. Say this is temperature, this is the number of swimmers. So, starting off as temperature goes higher, we know that the number of swimmers also goes higher. So, it would look something like this. And if we draw a line of best fit, it has a positive gradient, telling us that this is a positive correlation. Positive correlation will always have both variables increase with one another, while a negative correlation will have one variable decrease while the other increases. So we can tell that this is positive correlation. Moving on now to question 8. We are asked to find the first 3 terms of the sequence n squared minus 3. So to do this, we just take the values of n equals 1 for the first term, n equals 2 for the second term, and n equals 3 for the third term. So let's do that. For the first term, n equals 1, so 1 squared minus 3 is equal to 1 minus 3, equal to negative 2. Second term, n equals 2, so that's 2 squared minus 3, to 4 minus 3, which is equal to 1. And last but not least, the third term, where n equals 3. 3 squared minus 3 is equal to 9 minus 3, which is equal to 6, giving us the first 3 terms of negative 2, 1, and 6. Now moving on to part B, we are given the first 5 terms of a different sequence. So first, let's try to look at the terms we are given. Looking at these, we can actually tell that between terms, there is a multiplication factor of 3. As 1 times 3 is 3, 9 times 3 is 27, and 27 times 3 is 81. So this is actually showing us that it is a geometric sequence, as the difference between terms is a multiplication factor of 3. So to find the nth term of a geometric sequence, we use the formula a times r n minus 1, where a is the first term, r is the multiplication factor, and n minus 1 is the same. It always stays as is. So the first term is 1, the scale factor is 3, and we have n minus 1. Evaluating this, we just get 3, n minus 1, which is the nth term of this sequence. Now moving on to question 9, we're asked to find the coordinates of a point of intersection. So first, let's write out what we know. We know that the line has the equation y equals 2x minus 5. And we know it intersects at the line y equals 3. So let's draw a mini sketch. Show that at y equals 3, which is represented by this line. the line crosses at point P. This is P. So we can tell from this that the y-coordinate of P is 3. So with this, we can find the point on this line where y equals to 3 by substituting it. So this gives us 3 equals 2x minus 5. Rearranging this equation, we get 2x equals 3 plus 5. 2x is equal to 8, and thus x is equal to 2. X is equal to 4. So, thus, we know that the coordinates of P is 4, 3. Okay. Now moving on to our next question, question 10. We are given the diagram of a trapezium, and we're asked to find the area. So what's the formula of the area of a trapezium? Well, the formula is half times a plus b times height. So a and b are actually the lengths of the parallel sides, which in this case is SR and PQ. So, substituting that with 3.8 as the height, perpendicular to one of the parallel lines, we have half 5 times 5.3 plus 8.7 times 3.8, which is equal to half times 14 times 3.8 equal to 7 times 3.8, which gives us the final value at 26.6 centimeter squared. Moving on now to question 11, we're asked to work out 1 and 1 over 4 minus 5 over 6. Seeing as we have a mixed fraction, we should convert it into an improper fraction. So that 1 is the same as 4 over 4. So this is 4 over 4 plus 1 over 4 minus 5 over 6, which gives us 5 over 4 minus 5 over 6. And we know that to subtract fractions, they have to have the same denominator. And we know that 4 and 6 have a common factor of 12, where 4 times 3 equals 12, and 6 times 2 equals 12. Right, so we will multiply the fraction of 5 over 6 by 2, and 5 over 4 by 3, giving us 15 over 12 minus 10 over 12. Seeing as the denominators are now the same, we can straight away subtract, giving us 5 over 12 as our final answer. Now moving on to question 12, we are looking at another probability question. So we're asked to calculate the expected value. Well, the formula for the expected value of x, where x is the probability it lands, well, the number of times it lands on C, is equal to n, which is the total number of spins, multiplied by p, the probability of it landing on C. So this is equal to 40 times 0.35, which is equal to 14. So our expected value of it landing on C is 14. Now moving on to question 13, we are looking at bearings. So the way that we measure bearings is that we always start from up here at north, and then we go clockwise. So to first see the bearing of B from A is 107 degrees. So now this is 90. We know that 107 is approximately somewhere here. So from north to direction to B is 107 degrees. Now looking at the bearing of A from B, we know that we start at north, going all the way until here. We know that each quadrant is 90 degrees, so we know that the first three quadrants is 90 degrees times 3, as is 3 quadrants, which is equal to 270 degrees. That's 3 quadrants. Now to find this angle, we know that as the two north lines are parallel to one another, we can find that using alternate angles of parallel lines. So this angle, which we will call x, is the same as this angle, which we will call y. And that x is equal to y. Well, what's x? X, as you can tell by looking at this angle here, x is equal to 107 degrees minus 90 degrees, as x is only interested in this part here. So that is 17 degrees. So we know that y is equal to 17. So we know that this total rotation here is 270, which is the bearing of A from B, is equal to 270 degrees plus 17 degrees, which gives us the final answer of 287 degrees. Moving on now to question 14, we are looking at a train represented as this rectangle, which is 1,750 meters long, crossing a bridge, which is 480 meters. So we want to find the time, how long, for the whole train to completely cross the bridge. So as the train first moves, it will travel from the front of the train to travel across the bridge. It'll take 480 meters as it starts here and travels here. It'll be 480 meters. Then for the whole train to pass by the bridge, we have to travel the length of the train until the end has reached the end of the bridge. So in total, this is 480 meters to get from here to here, then 1,750 meters to get from here to here. Right? So we know that total distance. Let me just draw a dotted line to represent the start of the train. Is equal to 1,750 plus 480, which gives us the total distance traveled as 2,230 meters. Then we know that time is equal to distance over speed. Well, our speed is in kilometers per hour, so to calculate it, we need to convert our distance into kilometers. So from meters to kilometers, we know that we have to divide by 1,000. So to do that, we will write this as a fraction, and then we will divide it by our speed of 55 kilometers in 1 hour. And because we want our answer to be in seconds, we'll convert the hour to seconds by multiplying by 3,600. Because 55 kilometers in 1 hour is the same as 55 kilometers in 3,600 seconds. So then evaluating this equation, first flipping the dividing a fraction by inversing it and multiplying it, then giving us a final answer of 145.96, rounding it off to the nearest second at 146 seconds. Now moving on to question 15, we are looking at transformations. So first up, we want to see from triangle A to triangle B. As we can visually see from these triangles, the way that it points, the way that the side is pointing, is the opposite, meaning first that it is a reflection. And now we need to find where is the line of reflection. So to do that, we should find the middle point between two corresponding vertices, two corresponding points on the triangle. So we know that from 1 to -5, the midpoint is equal to 1 minus 5 over 2, which is equal to -4/2, equal to -2. So we draw a line at x equals -2. We can tell that the distance between the two, 1, 2, 3, 1, 2, 3, is equal, showing that this is a reflection in the line x equals -2. Right, as we can see, that is equidistant, same distance from the line of reflection. Right, now moving on to part 2, we're looking at triangle A onto triangle C. Well, first we can see that it is different sizes, thus meaning it is an enlargement. And to find the scale factor, we'll take corresponding sides and divide them by one another. Here this is 1, 2, 3, 4. Here is 1, 2. We'll take the new length over the old length, giving us a scale factor of a half. Right, looking once again at this, we know that from a length of 4 times the scale factor of half, the new length is 2. Right, so it's enlargement with scale factor of a half. And to find the point of enlargement, we will draw lines connecting the two points on the triangle and continuing the line. Try to cut that creak out. Okay, so we will connect points on the two triangles and connect the lines. So let me fix these lines to connect the points properly. And then we can see how all of these lines intersect at one point, which is the point -3, -4. So this tells us that the point of enlargement from the point, that it is enlarged from the point -3, -4. So to test this, we can see from this point to these corresponding points on the triangle, we have 1, 2, 3, 4, 1, 2 on the original triangle, times the scale factor of half would be 4 this ways, 2 this ways, and once this ways, we go from 1, 2, and 1. Right, showing us that we found the correct point. Now we're asked to draw the image, a triangle A, after a rotation of 90 degrees clockwise, about point 1, 3. So, first clearing our diagram, we are rotating from the point 1, 3. Let's mark that down first. So 1, 3. Okay. So that is 1, 3 up here. And this is our point of rotation. So let's try and move this point first. We know that is 1 this ways. And rotating clockwise, we bring it here. So this is our first point. Then looking at this point, we go 1, 2, 3, 4. To the right, 1, 2, 3, 4, downwards. Then rotating it once again this way, so we go 1, 2, 3, 4, and 1, 2, 3, 4, making this the second point. As you can see, we will take this point here and rotate it 90 degrees, still keeping it at the same point. Alright, so that is how we are moving these points. Look at this point, it is just a straight 1, 2, 3, 4, 5 downwards, and rotating it again is 1, 2, 3, 4, 5 here. So this gives us these 3 points, and connecting them together, we get the image A complement, A dash, which is the rotation of A 90 degrees clockwise, about the point 1, 3. And double checking the triangle, you can see that it's still the same size as 1, 2, 3, 4, and 1, 2, 3, 4, meaning that we drew it correctly. Now looking at question 16, we're looking at Venn diagrams. So you know that the total sample space is from x greater than or equal to 1 and x less than or equal to 10. Because it is such a small sample space, let's write down the full values of x, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Looking at set P, where x is an even number, we know that it is 2, 4, 6, 8, and 10. And set Q, where x is a multiple of 5, we have 5 and 10. Looking at set P and Q, we can see that 10 is shared, and thus it will go into intersection, showing it that it is part of C, as a part of P, and also part of Q. Right. Then looking at the other numbers, we can fill in their respective sets. Great. 5 is part of Q, and P has 2, 4, 6, and 8. Now looking at the remaining numbers, by cancelling those we've already written, we have 1, 3, 7, 9. So we will write that outside the 2 circles, as it is not part of either of those sets. So we have 1, 3, 7, and 9. So thus we've put all the numbers inside the sample space of E, and we have accordingly put them into their respective sets. Now looking on to question 17, we are asked to find the mean of a grouped frequency table, as we have a range of values that the height could be for each class. So the formula for this is the sum of HF, which is frequency, over the sum of frequency. So to find the sum of HF, we actually need to find the midpoint of each class. So to do that, we take the lower bound plus the upper bound and divide it by 2. So for this class, that would be 220 divided by 2, which is equal to 110. Keep doing this for each of the classes, and you will get the midpoint of all of them. And then from that, we can find HF by multiplying the midpoint times the respective class frequency. So this would be 110 times 32, and the sum of all of that, so that's 125, 55, plus 140 times 64, plus 170 times 49. Then that will all be divided by the total frequency, the sum of frequencies, which is 32, plus 55, plus 64, plus 49. Right. That then gives us the fraction of 27,685 over 200, giving us a final answer of 138.425 as the mean height in centimeters. Now moving on to our next question, we're trying to find the highest common factor, also known as the HCF, of 28x to the power 5 and 98x to the power 3. So we're going to do this in two ways. The first method using this diagram, where we write the two values we're trying to find the HCF for. And then we will look at the common factors. So the first one, between 28 and 98, is 7. And that 28 divided by 7 is 4. And 98 divided by 7 is 14. Then we also know there's a common factor of 2, giving us 2x to the power 5 and 7x to the power 3. And then we can take out x to the power 3 as a common factor, giving us 2x to the power square, so x to the power 2, and 7. So to then find the HCF, we'll multiply all these common factors together. So the HCF is equal to 7 times 2 times x cubed, which gives us 14x cubed. The other way we can do this is through the factors, by listing out the factors of each of these values. So this will look like this. So this is 2 squared times 7. As we're listing the prime factors, we will not write 4, but instead we'll write 2 squared. And then 2 times 7 squared times x cubed. So then looking at each of the corresponding factors, we will take the lowest version, the version with the lowest power. So between 2 and 2 squared, that'll be 2. Between 7 squared and 7, that'll be 7. And x cubed versus x to the power 5 would be x cubed, giving us an HCF of 2 times 7 times x cubed, which is equal to 14x cubed. Now moving on to question 19, we want to find the total distance traveled by the bus. So we know that in a speed time graph, as distance is equal to speed times time, distance traveled is actually equal to the area under the graph. And as we discussed earlier, the formula for a trapezium is half a plus b times height. So we have half, the value of a is 190, plus the value of b would be this gap here, which is 140 minus 20, as we're only interested between these two bounds, times the height, perpendicular height, of 15. So that gives us half 190 plus 120 times 15, giving us a final value of 2,325 meters. Now moving on to question 20, we're asked to find the area of this triangle. Seeing as it is not a right-angled triangle, we have to use the formula half AB sine C. In this case, it's not exactly A and B, but is the angle of 23 and the two sides that are on the other side of the angle. So that'd be half 4.9 5 times 5.6 times sine 23 degrees, which gives us an answer of 5.36 centimeter squared to three significant figures, as we do not get an exact answer. Now moving on to question 21, we are asked to find the value of h. So let's rewrite this root of 5 as a power of 1 over 5. And looking at this with the same base of 3, we can remove it, showing that h is equal to 1 over 5. Now moving on to 4x cubed and the cube of that. We know that for nm by a power of a is na times ma. So we know that it is 4 cubed times x cubed cubed. And we also know that for a and bracket m, we will be multiplying the indices according to the indices rule. So that gives us 64 times x to the power of 9, as is 3 times 3. So that's 64, x to the power of 9. Now moving on to question 22, we know that y is inversely proportional, so it's 1 over the square of x plus 3. Right, so we know that y is equal to a factor of over x plus 3 squared. Right, so now substituting about the version of values we know, we have 0.375 equal to k over 5 plus 3 squared. So 0.375 equals to k over 8 squared. K is equal to 0.375 multiplied by 8 squared, which is equal to 0.375 times 64, giving us the value of k as 24. So to find y in terms of x, we know that y is equal to, substitute k, 24 over x plus 3 squared. Now we move on to question 23. We're asked to draw the graph of y equals cos x for the value of x between 0 and 360 inclusive. So looking at a few key values of 90 degrees, 180 degrees, 270 degrees, and 360 degrees, we know certain values. We know that at 0 and 360, cos x is equal to 1. And we know that at 180, cos x is equal to negative 1. And at 90 and 270, cos x is equal to 0. You can find this by typing in cos 90 degrees into your calculator, and you'll get the appropriate answers. Right. Seeing this, we can kind of plot a general graph of cos x. Right, starting at 1 and following this shape. Yep. Thus, this is the graph of y equals cos x, where it is no more than 1 or less than negative 1. And try to make the graph look as symmetrical as possible, as we know that it is symmetrical around the point of x equals 180. Right, so this is our graph of y equals cos x. These dotted lines are just for reference to make sure that we do not exceed 1 or negative 1. Moving on to part B, we're asked to find and solve the equation of cos x is equal to 0.294. So to find our first value of x, we will find the inverse cos of 0.294, which gives us an angle of 72.9 degrees, which is our base angle. So we know that at 72.9 degrees, roughly around, let's say here on our graph, we have a value of 0.294. We get that same value along the graph. We know that it also occurs here. Seeing as this graph is symmetrical, we know that this gap here is the same as this gap here. So to find these angles, we know that the first one is 72.9 and the second one is 360 degrees minus 72.9 degrees, giving us final answers of 360 minus 72.9, which is 287.1 degrees. So these are our values of x. So if you type into your calculator these values of x, you'll get roughly the same answer, close to 0.294. Right, so we can tell through symmetry what are the values of x that give you the same value of y. Now moving on to question 24, we are trying to show the value of a and the value of b. So we'll tell that x squared minus 16x plus a can be written in the form x plus b squared, meaning that they are equal to one another. Expanding this bracket, we get that x squared plus 2bx plus b squared. So by looking at these equations and comparing the coefficients of x, we know that minus 16x is equal to 2bx. Cancelling out the x as we move it over, we get that minus negative 16x is equal to 2b, and b is thus negative 8. Now, we also know that a is equal to b squared, and seeing as we know that b is negative 8, a is equal to 64, thus giving us an answer of a equals 64, and b is equal to negative 8. Alright, so now looking on to question 25, we are told about a bag which has 2 green buttons, 5 red buttons, and 6 blue buttons, which I'll represent as this circle. So we're told that buttons will be taken without replacement. So that means if I take away a green button, there will only be one green button left, as we do not replace the buttons taken. So we want to find the probability that 2 buttons are different colors. So there are 2 ways we could go about this. First is that we could find the probability of buttons being the same color and subtracting that probability from 1, as we know that there are 2 outcomes, that they are the same color or that they are different colors. So trying that method first, let's first find the probability of green twice. So we know that the first green button, there are 2 out of the total, which is 2 plus 5 plus 6, which equals to 13. So we know that there's 2 out of 13 buttons, and then 1 out of 12 buttons, as is without replacement, giving us a value of 1 over 78. Then finding the probability of red twice, we know that it is 5 out of 13 times 4 out of 12, giving us a value of 5 over 39. Then finally, having a probability of blue twice, it is 6 out of 13 buttons multiplied by 5 out of 12 buttons, giving us a probability of 5 over 26. Then, therefore, the probability that the buttons are the same color is the sum of these probabilities, which is equal to 1 over 3. So the probability of different color is equal to 1 minus 1 over 3, which is equal to 2 over 3. The other way that we could do this is by treating it as a probability of a button and the color not being that button. So, for example, for green, that would be first taking a green button and taking one of the other 11 buttons, giving us a probability of 11 over 78. Probability of blue and not blue, we have one of the 5 buttons and then one of the 8 remaining, giving us 7 over 26. So this is for red and not red. Probability of blue and not blue, we have one of the 6 buttons multiplied by one of the 7 remaining non-blue buttons, giving us a probability of 10 over 39. So, thus the probability of different colors will be all of this added up, which is equal to 2 over 3 in the same way. Thus, that is our final answer. Now, looking at the final question, question 26, we are trying to find the perpendicular bisector of AB. So let's just sketch this out quickly. We know that A is 6, 1, B is 2, 7. This is an improper sketch. We start question 26. Going to question 26, we are trying to find the perpendicular bisector of AB. So let's do a quick sketch of this. We know that A is somewhere here at 6, 1. And we know that B is somewhere up here at 2, 7. So there is the line AB. We're trying to find the perpendicular bisector. Right. So to find this, we have to first find the midpoint of AB. So to do that, that's x1 plus x2 over 2 and y1 plus y2 over 2. So this gives us 6 plus 2 over 2 and 1 plus 7 over 2, giving us 8 over 2, giving us the midpoint of 4, 4. We also need to find the gradient of AB, which is given with the formula y2 minus y1 over x2 minus x1, giving us 7 minus 1 over 2 minus 6, giving us 6 over negative 4, giving us the gradient of negative 3 over 2. Now to find the gradient of the perpendicular bisector, we know that the gradient of a perpendicular line is the negative reciprocal, right? So this will give us 2 over 3. Then, to find the equation of the perpendicular bisector, we can use this formula, y minus y1 equals mx minus x1, where the values of y1 and x1 are the point at which the perpendicular bisector crosses, which is the midpoint. So it's y minus 4 equal to 2 over 3 x minus 4. So expanding this bracket, we get 2 over 3x minus 8 over 3. Moving this over, we get y equals 2 over 3x minus 8 over 3 plus 4, giving us a final answer of 2 over 3x plus 4 over 3. So that marks all the questions of Maths Paper 2 Extended of February and March 2024. Thank you for watching another video from Tutoring with You. Hope you have a great day.
Thank you for watching our video. If you found it helpful, please share it with your friends and family. Make sure to like, subscribe and turn on your notification so you can be notified when we post our next video. See you soon.